Hello everyone, we are now going to be talking about finding the derivative of exponential functions and logarithmic functions. All right, so just to give you a bit of an idea, when we have e to the x as a function, if we were to take its derivative by definition, in other words, the limit as h approaches 0 of f at x plus h minus f at x over h, and then we sub our function into here, we can factor out an e to the x, and by limit properties, because this doesn't have an h, I can bring it outside the limit, and it turns out that this limit is equal to 1. We're not going to prove this. If you want to try to convince yourself, try plugging in values for h that are, say, 0.1, and then try 0.01, and then 0.001, to show yourself that, yes, this will approach 1. So the derivative of e to the x turns out to just be e to the x. But more generally speaking, what happens if we have e to the power of some other function? Let's say some g of x. So maybe it's x squared, maybe it's 2x. Well, it turns out that our derivative for such a function is going to be e to the g of x, so we rewrite it. And then by chain rule, we're going to take the derivative of whatever is in the exponent here. Okay, so let me do a few examples with you. Normally in textbooks, they just say the derivative of e to the x is e to the x, but according to this rule, the reason is because by chain rule, if we just go d dx of x, well, this value is just equal to 1. Okay, so that's how we can get e to the x by following this rule here. Let's say we had e to the 3x, for instance. So we rewrite what we have, and then we have to take the derivative of the exponent. The derivative of 3x by the power rule, that's just going to be 3. And since these terms are multiplied together, I can switch their order. So I usually write coefficients first. And then we have 3 e to the 3x. All right, let's do a few more examples. So this function is called y. So if we want to differentiate with respect to x, we're going to use dy dx as our notation, the name of our derivative. Rewrite what we have, and then take the derivative of the thing in the exponent. And what I'm going to do is I'm going to rewrite it as x to the negative 1, because then by power rule, it's a little bit more clear to see that I bring down the exponent and I subtract off 1. Now remember, this is again being multiplied, right? So I can bring it out to the front. I'm going to have negative, and instead of having x to the negative 2, I'll go 1 over x squared, and then that's all being multiplied by e to the 1 over x. All right, now let's try this one. So we have our coefficient here, that's fine, we just ignore that. And then the derivative of this part, our e, we rewrite what we have, so e to the power of x squared plus 7, and then I have to take the derivative of the exponent. So d dx of x squared plus 7. So I'm going to rewrite this first part. Now that derivative is just going to be 2 times x. And because these terms are multiplied together, I'm going to bring this 2x to the front and multiply it by 2 to get 4x e to the x squared plus 7. Okay. That's good. Now, what happens if we just have a? Because remember, we looked at these exponential functions that weren't of e, they were of maybe 2, 3, something like that. So what happens for this type of function? It's very similar in the sense that we rewrite what we have, we take the derivative of the thing in the exponent, but we also end up getting a coefficient ln of whatever that a number is. Now, why is this the case? And this is good practice for taking derivatives. So we are going to go through this proof. So if this is the function that we have, what I can do is I can take e to the ln, because that's just 1. It's like they cancel. So I can express a to the g of x as e ln a to the g of x. And this was something that we looked at, this change of base. We looked at it before. Now, by ln rules or logarithmic rules, we have the g of x in the exponent, so we can bring it down to the front. So we can write e g of x ln a. And remember, ln a is just a constant. Okay, so if you want, you could write it as e ln a if you always want your constants in front. And if I differentiate this, I'm going to rewrite what I have. Okay, so I have e to the ln a g of x. But then by properties of e, what we just looked at, I'm going to have to differentiate the exponent part. So d dx of ln a, that's just a constant, so that'll come out front. And then I have g of x. So because this constant comes outside the derivative and all this is being multiplied together, I can just bring it directly to the front to get ln a, e to the ln a, g of x, and then d dx of g of x, well, that's just g prime of x. But I'll do an extra step here to just show that we took out that constant. All right. So then I get my ln a, e, g of x, or ln a, however order you want to write it, times g prime of x. Okay, so that's why that's true. That's the proof or the derivation of why that's the case. Usually in textbooks, they first introduce this as the rule, but I prefer to just do the general one so it'll seem less confusing. So what's our rule again? Well, I'm going to go ln of whatever that base is. So that's our a. Rewrite what we have, and then take the derivative of whatever's in the exponent. Now d dx of x is just 1. So I have ln a to the x. Now let's try one where we're going to have to use the chain rule. And instead of having a general a, I'm going to use 2 this time. So the derivative of that, we do ln of the base, rewrite what we have, so 2x squared plus 1, and then we take the derivative of the thing in the exponent. Okay, so we have ln 2 times 2 to the x squared plus 1 times 2x. And because these 3 terms here are being multiplied together, I'm just going to bring my 2x up to the front. And as I said, I usually prefer writing the constants first. So 2 ln 2, that's just a constant. And then it's times x, and then it's times our exponential function, 2x squared plus 1. Okay, now we're going to get a little bit of everything with some product rule. So notice that we have a function x squared and a function e to the x. So we think about that as the power rule, where we go the derivative of the first, so d dx of x squared times the second, plus the derivative of the second times the first. And then we're also going to have d dx of this thing here. So what is that? Well, I have to go ln of the base, so ln 3, rewrite what I have, and then I have to go d dx of the thing in the exponent, which is 2x. Okay, and actually, yeah, that's okay. My head's not in the way. All right, that's fine. Now let's see what this is. So the derivative of x squared by power rule is 2x. This is times e to the x. The derivative of e to the x is just e to the x times 1. So we can just write it as e to the x. And then we have plus ln 3 to the power of 2x. And the derivative of 2x is just 2. So again, I'm just going to bring this 2 up to the front so it's a little bit easier for me to read. And draw my brackets. So I get 2x e to the x plus x squared e to the x. You can leave it x squared if you want. Okay, whatever you prefer. Plus 2 ln 3. There's my constant. And then times my exponential function. And there we go. Now, what happens if we have a general logarithmic function? Okay, with any base. It doesn't matter what base it is. Well, it turns out that the derivative of this function is going to be 1 over ln a times x, or x ln a. I usually write it as x ln a, but you can write it however you prefer. Now, this also looks really mysterious. Why would this one be true? Well, let's go through the proof. It's also good practice for taking derivatives. Let's write it instead in exponential form, because we know what to do if we have a to the power of a function. So let's differentiate this entire thing, left-hand side, right-hand side, with respect to x. Now, if we do that, what's our rule for a to the power of something? Well, we're going to have ln of the base, rewrite what we have, and then we go dx of the thing in the exponent. So in this case, we would just get f prime of x. And then d dx of x, well, that's just equal to 1. So then what I can do is I can rewrite this expression, but notice something. This af of x, that's the thing that we called x. So what I can do is, because I know this is also equal to x, I can instead write ln a x, I'm going to bring the x to the front, times f prime of x is equal to 1. So now if we just rearrange and divide through by that x ln a, I get my expression. Now, something to also notice here. What if our right-hand side was a general function, let's say g of x? Then we would end up getting g prime of x. So if that was the case, instead of having 1 on top, we would have g prime of x, g prime of x, g prime of x. Okay, so that's something to keep in mind. We'll do an example like that in just a second. Okay, it'll seem mysterious, but that's the reason why we're going to get the answer that we get. But first, then we're just going to write down the case for if we have the natural log. Okay, and I'm going to do it in the general case of having g of x. So if we have ln of something, what we always do here is we go 1 over whatever's inside the ln, and then by chain rule, we take the derivative of whatever's now in the bottom. So usually when this rule is presented in books, they just normally write it as ln x, and then they say, okay, the derivative is just 1 over x. But the reason is because when you do chain rule of d dx of x, this is just equal to 1. So ln x is just 1 over x. Now let's do this example. So the 3 out front, so remember, the 3's can be factored out, if you will. And then we're going to go d dx of this ln. Now for ln, what's the rule? Well, we go 1 divided by whatever is in the ln. And then at the top, we want to go d dx of whatever's now at the bottom. So x squared plus 2. Okay, so we're going to have 3 divided by x squared plus 2. And then times the derivative of x squared plus 2, well, that's just 2x. So because these things are being multiplied together, I can write the top as 6x, and then divided by x squared plus 2. Okay, this was the example I was talking about. Log of 2, but instead of just having an x here, we have some function. So the rule is, remember, we go 1 over, we're going to go ln of whatever our base is, so ln 2, and then write whatever is inside the actual logarithmic function, so this 3x squared minus 4x. But because this isn't just x, when I do chain rule, d dx, I have to go d dx of the thing that was inside my logarithm. So 3x squared minus 4x. Sorry, that should be minus. Now, what is that? Well, that's just going to be 6x minus 4. And because they're being multiplied, I'm just going to directly put it on the numerator. And then all this is divided by the ln of the base times whatever was inside the logarithmic function. Okay, if this was natural log, so if it was ln e would just be equal to 1. So that's why this is gone. All right, now let's try this one. Now this one may be a little bit hard to look at, but notice that we have two functions. We have one here, this 3x squared, that's like an f, and then we have a second one here, which is like a g. So we are going to be doing a product rule here. We'll also have chain rule, but let's just first write out the product rule. So how do we do that? Well, we go the derivative of the first, so d dx, 3 e to the x times the second, plus the derivative of the second, so d dx of ln x squared times the first. Now, the derivative of 3 e to the x, well, the 3 we can take outside the derivative and think of it like d dx of e to the x, but that's just equal to e to the x. And then I have times ln x squared. Now, the derivative of ln, remember, we go 1 over what we have in the ln, and then we're going to have to go times d dx of the thing on the bottom, and then this is still times 3e to the x. So I'm going to rewrite what I have here, 3e to the x ln x squared. I'm going to bring that 3e to the x out front with the x squared. So 3e to the x divided by x squared, and then I have times 2x. Now I can simplify this a little bit. I have an x on the bottom, 2 of them, and I have an x on the top. So since they're being multiplied, I can get rid of a factor of x. And then I have 3e to the x ln x squared, plus I'm going to multiply the 3 and the 2 together to get 6e to the x, and then all that is divided by x. And then that is our solution. Thank you very much. I hope you found this helpful.